Hello, everyone. Welcome to this last session of the day. For the people in the back standing up, you can always, there's a couple of seats there as well. Uh, welcome for being here at this last session of the day, a session about indexing and searching NuGet.org with Azure Functions and Search. Now, the idea of this talk is to walk you through a couple of things that we've been building at JetBrains and have been experimenting with on Azure Functions. It's going to be mainly how NuGet works, how we can fetch data from NuGet, and how we can use Azure Functions with custom bindings to make it more easy for ourselves to index all of the public types that are available on NuGet and map them into NuGet packages that are available. So let's go. Find this type on NuGet.org. For those of you who have been using ReSharper or Rider, you may have seen this thing. When you start typing some class or some type that you are using in your code, you will see that, of course, it turns out red because it's not yet referenced in your project. But what will happen is if you Alt-Enter, ReSharper and Rider will suggest you that you can actually find this type on NuGet.org. It will do a search for that public type, and will actually install that NuGet package into your project. So that's a really easy workflow to just start working with unsupported types or unreferenced types and easily add the NuGet reference into your project. Now, of course, this has to work somehow. Somehow we have to store the data on what public types are available and to which NuGet package they map, and that's what's the session going to be about. So back in 2013, we were thinking about building something like this, and I think in 2015 we released this thing. And once we started building this, of course, we needed the ReSharper side of things to integrate with Alt-Enter and make sure that you can actually install whenever you search on the API and so on. But we also decided we needed a service to provide all that data for the clients so that you can actually install those things. Now, back in 2015, Azure was not the Azure of today. And we basically built an Azure Cloud Service with a web role and a worker role running the API, doing some of the indexing and so on, storing all of that stuff on, I think, even on a VM disk and somewhere in a database that we could query afterwards. Building up that index, we did based on the OData feeds that NuGet has available. For those of you who don't know OData, it's the GraphQL from the last decades. It's basically a way to query databases over HTTP, shape the result format that you want to have, run a query, get the data based on whatever parameters that you pass in there, and then start working on that. So the query you see on the slides there is basically the query that we use to fetch the latest packages from a certain date and index them in our service. Now, NuGet over time, in 2015, NuGet was a little bit different from what NuGet is today. NuGet over time has been growing. Actually, Alexander here, who I've shown the tweets of, he built a service and he looked at the disk space that was available, and he noticed that back in 2015, the repo of NuGet was pretty small and it grew over time. So NuGet has becoming more popular and there's more packages there, so more indexing work for us to do as well. Also, NuGet has announced last year that they would start signing all the packages that are on NuGet. And basically what that means is they have, at some point, opened up all of the NuGet packages, added a signature in those NuGet packages, stored them again, and basically added them to the NuGet.org feed again. So basically that meant that even when the repo was 2 terabytes approximately, it would mean that all of a sudden, after this package signing happens, all of those packages would reappear on the feed and we would have to re-index them, even though nothing really changed apart from that signature. So a couple of things. Also, we wanted to think about changing the way we were actually doing the indexing. So let's talk about the NuGet server-side API for a little bit so you can imagine how you could start working with it and fetch data from it. So NuGet, as you know, talks to a repository. It can be a network share, can be some HTTP or HTTPS server out there. And you query that server or you query that API and you can install packages into your project, right? It has 2 APIs, the V2 API, which is that OData-based one that works pretty well, and pretty much all of the NuGet servers out there support that protocol. But NuGet.org also has a V3 protocol, which is JSON-based and has been rethought after OData proved to be not the best way of managing packages or fetching packages on NuGet.org. So that V3 protocol is actually pretty interesting, but the time when we wrote our indexer, that protocol was not yet available, but it is now. That V2 protocol was interesting because it basically provided OData over HTTP to link to entities on the server at NuGet. So basically, any query you make against that OData endpoint results in a database query that is custom to you and runs some query on the database. So you can imagine if NuGet grows, it becomes a little bit slower and so on. And they added some optimizations, but for us, all we wanted was like give us the latest packages since the last time we ran this indexer. And we found that after a while, these queries became slower and slower and slower because, of course, it translates into a database that has to skip lots of records to only provide you with the latest packages that are in that database. So it works, but NuGet realized it's not the best protocol, and also for our use case, it was also not the best protocol. The V3 protocol is more interesting. The V3 protocol is, first of all, JSON-based, which is not bad, also not good. It's basically not XML, which is always nice, so it's less bloated and so on. But the V3 protocol is also interesting because they built it based on resources. They discovered that for NuGet.org, there were a couple of use cases to query the APIs that they had. So they came up with different resources that you could target depending on what you want to achieve. So for example, there's a catalog, which is an append-only event log of every package addition or every package deletion that happened on NuGet.org. Your NuGet client in Visual Studio or in Writer will probably not be using that one. But if you want to do something like we do, indexing NuGet, that catalog is actually quite interesting. There's the registration blobs. That's basically whenever you open up the NuGet dialog in Visual Studio, you query some packages and you look at the details like the icon, description, etc. That typically comes from the registration. When you do a package restore, that typically comes from the flat container, which is a by convention sort of disk drive where NuGet can find packages and download the binaries and install them. So that's a really nice API and really nice to have all those different resources to do certain things. And actually on GitHub, you can find codes that uses that API that you can use to work against any of these resources that are available in that protocol. So how does NuGet work? You see all these different resources that are available. Now, when you upload a package to NuGet, actually what happens is your data gets added to a database, so all the metadata, who owns the package, what's the package version, package ID, etc. Then that data is also added into that append-only catalog. And then based on that catalog, NuGet itself provisions its search service, make sure that that flat container is there, that the registrations are there, and so on. So we thought, okay, if they can run whatever infrastructure they have based on off of that catalog, maybe we can do the same as well for our ReSharper service there. So that catalog seemed really interesting. And in fact, if you go and look at that catalog, it's really one stream since the beginning of NuGet where you see all of the packages that have been added over time with a timestamp and their state at the time of that timestamp. So what that means is that that catalog is chronological. If you fetch from a certain date or until a certain date, you actually have the NuGet state of that certain dates that you were targeting on. So it allows you to do like a point-in-time restore of NuGet, but also allows you to query all the packages after X date, for example. The structure of that catalog, and I'll show you that in a bit in the browser, is basically you have a root. That root points to several pages that are available, and then every page has leaves that points to a certain package version with a description and a title and so on. I know this doesn't say a lot, but I will show you what it looks like. So if you look at the catalog, and basically if you go to the NuGet.org API at api.nuget.org v3 index.json, you will see all of these resources that are listed. So if you do a query in Visual Studio or in Writer, you probably run against one of these query endpoints. If you do an autocomplete while you are editing your project file, you will probably hit one of these endpoints. Whenever you, for example, need all the package details, you'll probably use this URL as the base to discover all those package details and so on. But somewhere hidden in this metadata file, there should be the catalog. There we go. And if you open the catalog, you will see that there's a giant JSON file that simply contains nothing except, let's wait for it to load, there we are, nothing except IDs, which point to a page in the catalog with a commit timestamp and a commit ID. Now this is interesting because if I want to fetch, for example, the packages that have been added in the last 2 days, I can scan this page or I can scan this root document and just fetch the pages that I need for that time range that I want to support in my service. If we go to one of these pages, you will see that such a page also contains much more data. It contains items, and every item is a package that has an ID, a type, which is either package details, which means something happened to this package but it's still available, or a package delete, which means that the package should be removed from search and from databases and so on. We get the ID and we get the version. And if we go to one of those ID URLs that are in there, you will see that you actually get back the author, the description, the language, last edited timestamp, and so on for every package. So by navigating all these endpoints, we can actually fetch all the data without hitting the NuGet.org database over OData and making sure that we're stressing their database a little bit. So that's a little bit how the catalog works in there. Now, find this type on NuGet.org. We have it still running on that cloud service, but we are refactoring it from using OData to using this v3 API. Now, we also were thinking, like, should we continue building on that thing, or should we rethink what we are doing? So we decided to also work with a serverless approach, which is this talk, basically, to rebuild whatever we had from scratch using that serverless approach. So welcome to this talk. That's what we're going to talk about for the rest of the talk. So building a new version of that indexer. What would we need to do that? We would need a couple of things. First of all, we would need something that watches that NuGet.org catalog, that scans for new packages that have been added, and so on. Then for every package that we discover on that catalog, we will have to, first of all, download it, extract it, look at all the assemblies that are in there, and somehow store the mapping between all those public types in there, as well as the package ID and the package version. And ideally, also an API that is compatible with the current versions and previous versions of ReSharper, so we don't have to ship updates to actually the client of our API that we have. So that's pretty much what we need. And bonus points for an easy way to reindex. There's always cases where you have to reindex whatever you have. So as a side edge case of some requirement that we wanted to have there, we would like to be able to reindex fast by copying the NuGet binaries and dumping everything into some JSON blob that we could really load quite quickly. Now, watching the NuGet.org catalog could be a periodic check. For example, every hour we could check the catalog for new packages in the past hour and do something there. You already feel that doing that check, we could also push some messages into a queue somewhere. And for every package that gets added, we would add a message to a queue somewhere, then process that message and do whatever we have to do to make that indexing happen. And then, of course, we have our API, but that could be just any API that just provides JSON over the wire. Sounds a bit like functions, because if you look at the marketing slide text that a lot of Microsoft people will give you, you will see that this is Azure Functions. You have input, processing, and outputs. That's really nice because pretty much all the software out there does this. But the really cool thing is that the input is basically triggering the fact that some code has to run. Your code will do its thing. And when that code has finished, it will provide some output that is then processed by the functions runtime. So basically what this runtime gives you is code that will run when something happens, event-driven code basically, but also conventions to get input and write output from that function. So basically what it promises is that we write our codes, the inputs, we can use a collection of whatever we want to use as the inputs, and when we have output from our functions, we write the outputs to the output binding in Azure Functions as well. So we decided, okay, let's think in functions, and what functions do we need? Well, of course, we need one function that watches the catalog, one that watches NuGet.org for new packages. Then we would have a couple of queues or queue subscriptions where we would put indexing commands as well as downloading commands. What we wanted to do was mirror all the binaries on NuGet.org so that we could easily reindex whenever needed without stressing NuGet.org itself, but also the indexing itself. So we would have two other functions, one for indexing and one for downloading. Then we would have a search service, which would contain the entire catalog of public types and whatever package ID and version they map to, and our API maybe as a function as well. So let's see if we can build this. So collecting from catalog. Let's start there. If we look at how the catalog is structured, you have these timestamps and these pages and so on. What we can actually do is make use of some of the NuGet.protocol.catalog libraries that NuGet has on GitHub to loop over that catalog. And if you would do that, and let's look at the code here, what you get from that NuGet package, and I actually reference the sources, but you can also use this as a NuGet package. What you get there is that you have the concept of a cursor. You have a timestamp that you follow while reading that catalog. You also have a batch catalog processor, which is something that reads from this catalog that makes use of this cursor to see which packages have been added or deleted at some point in time. That has a client to that catalog and then some processing whenever a package is added or whenever a package is deleted. So using nothing but everything that is standard in that NuGet package that NuGet itself provides, we can simply write something like this where we write the adds to the console, for example. So let's say we want to fetch the packages from the last hour on NuGet. We can do that and say, okay, give me the last 1 hour on NuGet. If we would run this, you would see nothing will happen for a while because we are reading that index page and all of those catalog leaves that are available. But at some point, you will see that we start outputting all the package IDs and package versions from the last hour. So really easy to write, but also very fast because it's just downloading JSON from a CDN somewhere and making that happen. And since Norway has really good internet speeds, this was really fast. And I'm actually pleasantly surprised about the speed of this. So these are the packages from the last hour live from the catalog. So that's nice, nice to do. Now, what we can do is we could make this into a function as well. So what we can do is write a function that triggers, for example, every 15 minutes and runs pretty much this code and adds things to some queue. So that's basically what we can do here. Let's add a new timer trigger. Let's do that. Let's add it to Git, fine. And let's keep the defaults. Let's run it every 5 minutes. And then we can say we want to run that trigger. Pretty much the same codes with a couple of differences. One difference would be that in this case, our cursor would be based on the timer that we have here, so my timer. Because that timer that we get from Azure Functions gives us the last time the timer ran, but also the next time the timer will run. And since we are querying this catalog based on timestamps, that's perfect because we have the exact window for this timer and the next occurrence of the timer and the next occurrence of the timer to run it. So when we do this, we can basically use the same codes and log something, for example, to the console in this case and see if that runs or doesn't run. Obviously, instead of logging, you would in here add something to a queue and then make sure that we can process that queue. But just to give you the idea, it's taking the same code from our console app and running it in an Azure function that we can use. So let's try that. Let's start my storage emulator as well. So we can actually run it. And when we run this one, I still have something going on. Yes, I should make this an async task as well. So once we have this and we run this, you will see basically exactly the same demo that I had before, only this time I'm already serverless. I have a timer function triggering that thing every 5 minutes. Let's allow the firewall here. Security is overrated anyway. There we go. Our function should run, and at some point you will see the output starting to come in from the last 5 minutes, for example. Now, I know I said 5 minutes here, so that means if nothing happened in the past 5 minutes on NuGet, we will not see anything, but you get the idea. This will run, this will create a catalog, and every 5 minutes we will see items appear in the log there. Okay, so yeah, let's not wait for it. Trust me, it will show up eventually when someone uploads a package. If you have a package, feel free to publish and you will see it come by there. Right. So collecting from the catalog is easy. We can use a timer function to do that, write something into a queue, or do something like the indexing immediately in that function, but that's not ideal. If you've heard about Paul D. Johnston, that's actually the guy who worked on Lambda at Amazon, and he wrote a series of best practices for functions, and there's a couple that are really important when you start looking at functions. And one of those is that every function should only do one thing. Of course, there's always going to be exceptions and so on, but ideally, your function should only do one thing and do one thing well. Why? Well, it makes error handling easy. It makes scaling easy because you can just scale one function in your application instead of an entire functionality in your application. And by doing this, you also immediately have to think about starting to split up your architecture into using something messaging-based. So let's see if we can make this better, and instead of having that timer to do things, come up with something else. So let's create a better version of this. So what I did, and I'm going to go through existing code right now. What I did was I created the enqueuer function here, which does exactly what I have been doing, using that same catalog client, going over the catalog and so on. But instead of adding things into my search index manually and doing all those things, what I'm doing here is adding things to a queue. What I'm adding is a package operation with the package ID, package version, and so on, so that afterwards I can start processing whatever is in there. Next, I will have an indexer function that listens to this queue based on a queue trigger and then does something with it. For now, we will only let it log the fact that a package was added on NuGet.org, but you get the idea. One will enqueue things, and the other one will actually do the processing of these messages. Now, what is interesting is this queue trigger binding. You already also see that in the enqueuer, we have the queue as an output there. I told you that a function has inputs, does some processing, and then has outputs. This is where that comes into play. Whenever you want to trigger something based on a message, you may have a queue trigger that provides you with the run command for your function, but also with the input for your function. So we get from our queue with a specific name, we get data that we can work with, namely a package operation. On the enqueuer side, instead of writing to the queue manually, what we do is simply add an element to this queue collector, and this queue collector will write to a queue with the name indexing queue in this case. So that's what we are doing here, leveraging Azure Functions to not manually fetch data and write data into some output storage that we want to use. We are actually leveraging the fact that the runtime gives you this data if you want to do that. So we started thinking, would there be a better version of building our own system? And actually, if you start looking at the different bindings that are available, there could be a better way of building things. Out of the box, Functions ships with the timer trigger, the fact that a message appears on a queue, maybe something happens on Event Grid or an Event Hub and so on, and those things can trigger your function and can give your function inputs. There's a couple of bindings that can take output from your function and write it into some backing store. Now, the interesting thing is that those bindings, you can build them yourself. I have seen SQL Server bindings. There's a SendGrid binding to send emails whenever something completes in a function. There's a Dropbox binding that I have seen. So what if we could create like a NuGet catalog binding to move all of that catalog collecting logic outside of the code of our function, and in there only do whatever we have to do, which is the thing that we want to do well, the only thing. Now, for that catalog, that would be an ideal case to have a trigger binding, a custom trigger binding. Why? Well, because we have that catalog and we only want to do something when a new package appears on NuGet.org. So that's an ideal queue trigger or trigger binding because it triggers our function logic, but also provides input to our function. Now, the problem with custom trigger bindings is that they are not officially supported yet. Yet we thought, well, let's build one anyway. And up till now, it's been running for 2 months now. We only had to restart the function app twice so far because the trigger stopped working. So it's not officially supported, but it works pretty well if you have some monitoring enabled. So let's see if we can create our custom trigger binding there. Right, second approach. In this case, our enqueuing function is now much simpler. We still have our queue to which we will write the outputs. We still add our outputs to a queue where we will process the logic, but instead of having all that catalog reading code in our function, now we have a binding called NuGet catalog trigger that keeps some blob somewhere to keep track basically of the cursor of where we are in the catalog reading packages. And whenever that thing triggers, we get a package operation, and all we do in our function is forward it into a queue so we can process it later. Okay. Let's look at that NuGet catalog trigger because that's, of course, the custom code in which we wanted to do the custom triggering based on the NuGet catalog. So that attribute is basically a data class to which we can provide some options for our trigger. In this case, we give it the service index URL, where is NuGet.org's API located, so we can change that if we want, a connection, and some place where we want to store the cursor of our application as well. That cursor is important because that cursor, and let me quickly show you in our storage account, if you look at, if you want to keep track of where you are in the catalog, you have to store somewhere where you are in the catalog, which would be a timestamp. So what we did was we added that, and we now have a cursor where we can store that timestamp. So that's why we need that cursor property in there as well. And we can give it a name, so we can run multiple of these bindings if we want, and so on. But basically, we want to store a timestamp of when the last package was retrieved from NuGet. So that's that. Right, so nothing special here in that binding attribute. What is special though is the fact that we say, okay, this is a binding. Now, if you read the documentation on the Azure Functions custom binding stuff, you will see that this is all you have to do. Well, it's not all you have to do. So you have to add this attribute called binding, but what you also have to do is create, first of all, let me quickly move that one away. First of all, you have to create a configuration, which is a config provider, where you say, okay, I have an extension to the functions runtime called NuGet catalog. I have something that provides a trigger extension configuration. Very long name, but the name has to match with the fact with the name of your trigger as well. So it's kind of by convention. And you have to add a binding rule. So basically what we say is, functions runtime, whenever you see this NuGet catalog trigger attribute, I want you to bind it to a trigger that is created by this trigger binding provider, which is of course another class that we have to implement. Now, to get everything registered, this is not yet enough. You also have to add a startup class, and in that startup class, basically register the fact that you have a NuGet catalog trigger extension provider, because otherwise the runtime will not pick it up. But once you have this, you can start creating your own binding. So what does that binding look like? Our binding has this attribute, of course, which provides the options. It has this thing that basically binds the fact that you can have a parameter to the fact that you can have a binding. And then we have this binding provider, which will do some more work. So what this one will do is whenever the function runtime decides it has to create a binding for you, or an instance of this binding, it will go through this code, fetch the attributes so you can set some options and so on. If the binding is supported for a specific parameter type, if not, we throw an exception. If it is, we start creating whatever you want to have. So we want to have a reference to a blob client where we can store that cursor in blob storage. We want to create it if it doesn't exist yet, and then we really want to create our catalog trigger binding itself. The binding is where the cool things start to happen. So the binding itself has a listener. Because you have an input binding that listens for something and then triggers the fact that your function has to run, you have to create this listener as well and create an instance of something that listens for data. I will go through this one later on because that's the most important one that we have here. But I will also go to the fact that you have to, or at least you can, provide additional data contracts for binding the data that you will provide from your binding. If you're only doing .NET code, this doesn't matter at all, because .NET will do strong typing, it will use JSON deserialization, and everything will magically work. But if you want to use a NuGet catalog trigger binding that we are creating here, written in .NET, but process everything using a Node.js function, for example, what you will have to do is basically provide the shape of your JSON that you will push into that Node.js function that you're writing. If you want to do a PowerShell-based function, same thing, you will have to add all this stuff to basically give it the shape of the data that you will pass in there. So when we have that, we can create our NuGet catalog listener, and this is where everything that we've seen so far starts to happen. So what we have there is, again, we have our batch catalog processor. We have a cloud blob cursor, which uses that blob to store the timestamp of where we are in the entire catalog of NuGets. We have our catalog client, and then something that handles package added and package deleted. These two are quite important because they will trigger, first of all, the fact that our function has to run, but second of all, they will give the data to the function's runtime that will be passed into the function that we are actually running. So what will happen is, if my package added is called, I call on executor a try execute async. I give my trigger value all the data that it has to have, and then that's pretty much it. This is basically telling the Azure Functions runtime, whenever I have data, run this function and give it this JSON blob of data that it can work with as a binding. So that's what's happening here. Once we have all that, let's see if we can actually make it run. I was in this one, right? I have added an option especially for demos like this, where I can say previous hours equals 1, so I can get the data from the last 1 hour. And if all is well, let's quickly see if I still have that blob in my local storage account. I don't think I have, but just in case, let's check. When we run this, we will get the data from the last hour in functions. So if we look at our blob containers, we have our triggers. And just to make sure, I'll remove all of them. There we go. So when we run our second approach, you should see at some point packages start to come in and items being added to a queue, and of course still logged to the console that we have here. So everything starts to run. Our functions are triggering. Something is happening. And you see it is already executing based on packages that are coming in from NuGet. So you see that a new message was detected on the indexing queue that has a package ID and so on. So you see that we have some Slack package with some version ID that was apparently added to NuGet.org in the past hour, and we can start processing that one. Right, so it's still running, so a couple of packages in the last hour, but we have our trigger working. It's pushing data into our function, and we can then push it into a queue and start processing that queue and do the actual indexing of packages that we want to do. Right, so this is running. I'm gonna not keep it running. It's not super important, but you get the idea. Now we have a very clean function where we bind to data that we want to monitor. We get the data into our function. We then process whatever data comes in and make sure things happen and that our application can actually run. Right? Good. Now we're making progress. We already have something that is now watching the catalog and adding those elements into queues that we can then process to do both the downloading as well as the indexing. Now let's look at the next steps in the pipeline that we are building, and let's start with the easy one, which is downloading packages from NuGet when a download message appears in the queue. So downloading packages. To download packages, let's go into this one. I have a download to storage function, it is called, and it listens on a queue that is called my downloading queue. So whenever a package is added by the thing that we just wrote, by that binding that we just wrote, this queue will trigger because there's a new message in that queue. And instead of writing to a blob ourselves, we bind to input from that queue, but also to output towards a blob. As you can see, this output binding can also use parameters in the name of that blob that we have from the incoming message. So we get an incoming package operation. That package operation has a property called ID and version normalized. Well, we're actually using that input data to generate a file name for our output data. So again, not writing the blob access code ourselves, but instead making use of those bindings to have that input, have that output, and concentrate really on the processing that we have in the application. So for downloading, I have two things. I can have an add operation or a delete operation. The delete is pretty simple. For the package blob that I just binded to, I run a delete if exists, and that's pretty much it. Delete the package from storage, right? Whenever an add happens, I do a little bit more. What I do is connect over an HTTP client to the package URL that I'm trying to download, and then upload to a stream on that package output blob where I want to write this. So not super complex. I'm fetching input, fetching output, or fetching input and writing it to the output and making sure that things appear in blob storage. So that's all there's to it. Now, I do want to give you one additional hint, which is if you do Azure Functions and you don't use like a static HTTP client or use the HTTP client factories and so on, you will quickly face TCP port starvation, because every single time when you new up an HTTP client in a function, the port will be reserved for a while and you will see things failing. So quick tip, if you need an HTTP client in your function, always make it static or make use of the appropriate approaches instead of newing up one for every single function execution that you are doing. Right. Cool, so the downloading is done. That was easy because it's just fetching data from one URL and copying it into another URL. Now let's look at indexing packages, making sure that we can actually crack open that package, get those public types, and map it somewhere to the package ID and the package version that we can install into ReSharper or using ReSharper. The indexing, there's a couple of things that we want to note there. A NuGet package, I don't know if you've ever done this, but a NuGet package is just a zip file that you can open. And in that zip file, you will see all of the different assemblies that are shipped and being added to the projects where you add them to. Now, the last thing we want to do in the functions that we are running is use reflection and assembly.load from, because that would mean that for every single NuGet package, we are really loading the assembly into memory. In theory, it would mean that the assembly could be executed or something could happen with it. And there's also no guarantee that the assembly will ever leave our runtime host again. So we don't want to do that. We don't want to use traditional reflection. We simply want to access the file, get the public types, and be done with it and have no trace of that file anymore in memory in our function. Turns out there's a nice NuGet package that you can use for this, System.Reflection.Metadata, and that really only opens a file pointer to the assembly that you're interested in, cracks open the headers that are in there that are describing the assembly, and you can then use those headers to work with and get the public types that are in there. So we could use that library to fetch all that data and then store it into Azure's database or into Azure Search or into a Redis cache or whatever we want to use as the store. Now, the System.Reflection metadata is, of course, a NuGet package, but if you use one of the decompilers that are out there, you can actually also see what is in the PE headers of an assembly in .NET. So if you open up any assembly, you will find that there are some headers, and in those headers, you will see that there is a dictionary called type definitions, or typedef. In that dictionary called type definitions, you will find all of the public types that are available, not as a name and a namespace, but as pointers to something else. So you'll see all these numbers in the decompiler there. Those numbers reference to some string in another dictionary in that header, and that header is in strings. So those names we can fetch from strings. So what we will have to do is crack open the assembly, look at the headers, get those pointers to what the public type names are, and then read the strings that represent what those type names are. In code, it's pretty much the same. We have our portable executable reader from that library on NuGet. We can then read the metadata from that portable executable reader. For every type definition that we find in there, we will then loop over them, get the pointer to the namespace, get the pointer to the name, and then use that getString method to actually get the name and get the namespace and process that as well. So if you ever need to fetch public types or do whatever you want to do with an assembly where you don't really have to use reflection, use something like this, because following pointers is easy. It takes a while to get used to it, but it's quite easy to do. You get all that data, it's super fast. It doesn't have to load the assembly into memory, and your runtime is not really polluted by the fact that you are loading that assembly. Then, when we have those namespaces and types, and we already have the package ID and the version, we of course have to store it somewhere. We chose to go with Azure Search. I don't know if it's ever going to be something that we will keep using or not, but for now it works quite well because it's an actual search engine, which means we can do some additional filtering to what a stupid blob storage or key value pair database would do. In Search, we can define one index that will hold documents, and those documents will contain fields that are searchable, which means we can search in them, that are facetable, which means we can filter on them, that are filterable, which means we can filter on them or group by on them, sortable, so we can give the newest results first or the oldest results first, etc. And really important, retrievable. If you're using Azure Search, you have to think about what a specific field should support, because that's what your index is going to support. If you only want to be able to search on a type name, but not retrieve the type name to display it in your API, your field can be searchable, but not retrievable. But if you still want to be able to fetch the type name from your index, you will also have to make it retrievable. So that's something to think about up front, and it's really difficult to change it afterwards unless you do a reindex of your entire documents. Now what we will do, since Azure Search also has a way of indexing data based on either manually adding it through their API, but also through uploading JSON blobs to a storage account, we will also, in our function, write data to JSON files so that whenever we have to do a reindex, we can point Azure Search to a blob container so they can do the import for us, which is our site's requirement of reindexing that has to be fast as well, right? So let's go into that and let's see how we can index our packages. So again, we still get the incoming stream of packages from our NuGet catalog trigger binding. And we also have the package indexer running, and the package indexer will actually do the indexing in Azure Search. So what the indexer will do is, first of all, whenever it launches, it will create a new search service client and create the index on Azure Search. This one can be done by convention, so all I have to do is create a package document class, and that package document class will contain all of the properties that I want to have in my search index, and also whatever they should support. So for example, we want to be able to search on package ID, sort on package ID, group on package ID, and retrieve the package ID as well. So those things we want to be able to do with this. And now when we create the index based on this class, we can simply use this class as a data transfer object into the API of Azure Search. Now, our function will run at some point based on the queue trigger, again, the indexing queue that I'm populating with data that I want to index. And as I told you, we also want to write to a blob a JSON file that contains the data that we just indexed. Why? Because of the faster indexing in case we have to reindex the entire Azure Search thing. Deletes are quite easy because a delete will, first of all, delete my JSON blob, and second of all, from my index documents, fetch the package by ID and by version, and then delete the document. So deleting is very easy. The adding is slightly more complex, but still very doable. So whenever we get a package add, what we do is, again, we fetch the package from NuGet. So we have the zip file containing all of the assemblies and so on. Then we open up the stream. We use this package archive reader to get access to all of the assemblies, but also to the metadata of our NuGet package. So we get the identity, description, package ID, package version, title, authors, tags, etc. And we already add that into a package document, which is eventually the entity that we want to index on Azure Search. Next thing we do is, for every target framework supported by our NuGet package, we will find all of the assemblies that are in there, and at some point open them up using this PE reader library that we have. Then we check if the type definition is public, because that's the only thing that we're interested in, right? If that's public, we get the namespace pointer and get the string for it. So we have a type namespace, but also the type name. Then we do some additional filtering because there's always some generated classes in public that are public in NuGet packages, like generated link classes and so on. So we want to filter them out. So we're not interested in those. But if we don't hit that filter and we still want to index this type, we add it into a type names collection containing the namespace dot type name, just so we have all the public types and public namespaces in one, basically, hash set of strings. Once we have that one, once we have all of the public types that are available in the package that we are trying to index, what we will do is add it into our package to index document that we will ship off to search, then add it to our index actions dictionary that we have as well. So we want to say, okay, we want to add this into Azure Search. And then at some point, we're also going to, and I actually uncommented this, what we're also going to do is create a new index batch to talk to Azure Search and to upload data in our index. And when something goes wrong, we deal with that and so on. So a lot of codes to basically take the document that we just created and push it off into Azure Search. Now, I already mentioned that functions should do one thing and do one thing well. And our function, in my opinion, shouldn't really care about the fact that it's using Azure Search and what the index operation should look like and all of the error handling related to indexing things in Azure Search and so on. So a better way of doing things would be to, again, leverage that concept of bindings and create our own output binding. So that this time we could simply say, okay, whatever function runtime, here's the package that I want to index, or this is a document that I want to add into Azure Search, deal with it. That's what I want to be able to do. So let's create our custom output binding this time. The code that I will have is roughly the same as what I just showed you. So when a package add happens, we will index, and all of that code is still the same. But instead of doing all that boilerplate, adding things into the NuGet or into the Azure Search service, what we will do is make use of this document add collector. And that document add collector will make use of our newly to create Azure Search index binding. Again, we will have an attribute where we specify the name of the search service, the access key to it, the index name, the index document type, etc., etc. But still, instead of manually adding everything to the index, we want to simply say, okay, document add collector, here's a package metadata that I want you to add to Azure Search and index for me. So let's look at how we can do this. The Azure Search Index attribute, again, is something very simple that simply contains all of the data that we want to have as configuration values to our binding. Again, we have to annotate it with a binding attribute there. The other thing that we have to do is, again, add a Azure Search extension config provider. That is also an extension. And again, in our startup, we have to say, okay, we are registering this thing as an extension to the Azure runtime. Once we have that, we can start working with our binding and start creating the output binding that we want to have. So this output binding in the configuration, we are saying, okay, I want to add a binding rule for everything that has the Azure Search Index attributes. This time, we're not creating a trigger binding. We are creating a collector, which means we collect data and ship it off to the Azure Functions runtime. And we bind to a collector for open type. I'll cover that in a bit. And we create an Azure Search async collector builder for that open type. Now, this open type is kind of interesting. What I could do if I wanted to quickly create this would be creating something that in my binding would not say that just ships a package document. What I could do is here also put package documents, and my binding would be much easier to write. Now, by using OpenType, we can basically pass in anything we want into this binding. And that's important because maybe we want to reuse this Azure Search binding to index other shapes and other types of documents. So we want to use this OpenType. That's an Azure Functions runtime internal type to basically specify, I don't know the type yet, it's something dynamic. We then create our Azure Search async collector builder, and that one will perform the conversion from the open type to the actual type. So what it will ask for is the functions runtime will see that I want to write into an async collector that writes package documents. What will happen is the runtime will call into this collector builder and say, okay, based on this attribute, give me an actual collector for an actual type instead of this open type that I just registered for. Then my search collector will be the thing that actually handles searching. So what it does is it creates a search service client so I can talk to Azure Search. It connects to it using credentials. It gets the index client, and then we'll create the index as well. In my attribute, I also specify whether I want to add, merge, or delete items in my index. And based on that, I will call a different methods in this collector that I have. Now, whenever in my function, let's go back there. Whenever in my function I run an add and my add writes to my, where is it? Should be here somewhere. Anyway, at some point it will write to my collector. What will happen is that in this class my add async is being called, and what I will do is do the indexing there for my function. My function doesn't have to care. The function simply gives me the document and I will handle the indexing and make sure that all of that happens. I also do some error handling there. So for example, when the index doesn't create, I will recreate the index and things like that. So the function no longer has to care about it, and the function will only have to index the package or create the document to index and the document that I will add into Azure Search. Good. So with that out of the way, we're almost there. All we need now is the actual APIs that ReSharper will talk to. And those APIs I will create using the standard trigger binding in Azure Function or the standard HTTP trigger. Basically, this is a trigger that, again, provides input to my function. In this case, it will give me an HTTP request that will live at a certain route at the endpoint of my Azure Functions, and then will do whatever I write in that function to do things. We could have written this as a simple web API as well, but we decided, okay, we're doing functions anyway. Maybe we want to be able to scale that HTTP service as well, so let's use HTTP triggers there. Right, so let's see if we can make this work with ReSharper and Writer. So we have the indexing out of the way, we have the downloading out of the way, and what we now want to do is provide something on the web that works as my find type API. Now, there's a lot of code in there, and most of it is specific to just formatting to the format that ReSharper expects, but I'm just going to quickly cover a couple of things. We have two APIs, one to find types and one to find namespaces. So I created two functions, function name find type and function name find namespace. And both of them listen to an HTTP trigger, which means my function gets triggered when an HTTP call comes in. It will give me my request where I have all of the query parameters that are passed in, and then I can run whatever I want to do. In my run internal async, what I do is fetch all of the other parameters, build my search query that I will launch against Azure Search, then actually launch that search against Azure Search, and then fetch all of these documents, do some filtering and so on, and in the end, return results there. Now, I have that API running, and if you hit NuGet type search.azurewebsites.net, you will actually see this API where you can search, for example, for JSON convert, or if you search for JObject, you will find, based on Azure Search, based on the index that we have, all of the types that are in there. So using all of this code, indexing everything, we now have an API that gives us back JSON that we can then use in the actual tool as well. So if we look at ReSharper here, we could write something that uses a JObject. So let's say var JObj equals new JObject. There we go. You will see that this object is not yet referenced. We now get the alt-enter quick fix to find this type on nuget.org, and actually configured ReSharper to reach out to the custom API that we built using functions. And you will see that even in ReSharper, this works. We get a package, we can install it, and make sure that we can start working with whatever we wanted to start working with. So quite nice, very nice workflow. We can scale everything separately. We have the web API there where if we have no users, there will be no web API running anyway. If there's a lot of users, all of a sudden we can scale up and get more API functions running in the functions runtime. Right, now there's one issue left that I didn't cover. If you look at the details here in ReSharper, you will see that we also have a download count there. To be fair, this data is fake. Our API is simply returning a random number as the download count. It would be nice to be able to use the download count for the actual indexing and to provide better sorting and filtering and so on. But there is one issue. NuGet doesn't have an API to give us that download data. So what we could do is, again, use either the search service that they have or use the OData API to fetch the downloads count for every package that we are indexing. But it would mean that we would have to re-index every week, for example, all of those downloads counts and really stress NuGet with fetching data for millions of packages. So we don't want to do that. We've opened up an issue with them, like, can you please give us an API with the download counts for all the package IDs and versions that you have? So if that ever comes to fruition and appears on the internet, how would we update our index, our search index, with all those download counts? Well, ideally, in our world, that download count data is simply a hash of package ID, package version, and the download count. And what we can do on Azure Search is do a package downloads, documents merge. So what we can do is query the existing document in search and simply update one property. And turns out that's actually a really simple API. You simply pass it the properties that you take as the identifier, which will be package ID and package version, and give it whatever properties you want to update, and it will touch just those properties and re-index just those properties. So that's the one issue that we have left for this one, and I do hope that the API will appear at some point. So we're done, right? We have something that indexes NuGet. We have something that downloads the packages. We have something adding data to an Azure Search index, and we have an API that consumes it. So the entire story is covered. We took this existing feature and built it in a serverless way that we can now scale. So we have all of those, and we also decided to build those trigger functions to reach out to the catalog and see what is happening on the catalog, and also an output binding to write into Azure Search to really make the programming model much easier to work with. And instead of having to think about how do I write data to Azure Search, I just say, okay, runtime, here's the documents that I want you to index for me using that custom binding. All of our functions can scale and also fail independently, which means if all of a sudden indexing fails, there's no issue. The API will still keep working and so on. We just don't get any new packages. We can scale the API independently. If there's all of a sudden a lot of requests coming in, we can scale that one independently. We don't have to add more function runtime workers to index packages, for example. To give you some background, our current OData-based ReSharper search that we have takes a good 2 weeks to index the entirety of NuGet using a pretty beefy machine, a good connection, and probably stresses NuGet quite a bit using that OData API. This one, we ran it for at the start of May on 2 B1 instances, passing along all those messages and passing along all those indexing tasks and so on, and it took us 12 hours. Which is a giant win coming from those 2 weeks in the current approach that we have. But also, I think if we scale it to bigger instances that have better throughput and so on, we can even bring that time down and do a full reindex of NuGet every 6 hours, for example. I don't think we need it. 12 hours is probably okay, but just to give you an idea, this actually really improved the throughput of indexing NuGet. We also found that NuGet is lying to you. If you go to the NuGet.org homepage, you will see there's like 1.7 or 1.8 by now million packages listed according to NuGet.org. According to the catalog that we scanned entirely, there's 2.1 million packages on NuGet. So there's a slight discrepancy there. No idea what it is, but there's more packages to be found on NuGet. In that catalog, we discovered 8,400 catalog pages with about 4,200,000 catalog leaves, which is roughly the double of the amount of packages that are available on NuGet. And that also explains the fact that they re-uploaded all of the packages with that NuGet package signing signature feature at the start of this year. So basically every package is in there twice for now. Some closing thoughts before we all can leave. When we would deploy this and we would take this to production, we would probably take separate function apps, not only for costs, but also for scalability and making sure that those functions don't interact with each other in terms of memory and CPU usage on the Azure Functions runtime. So what we would do is probably put search separately, put the indexing separately, and put the web API separately, because the catalog trigger can run on a very simple instance and only one, because there's only the catalog, and that's quite an easy task. The indexing we would run separately, because we can scale that independently. If all of a sudden all of the packages have to be reindexed, we can scale that separately from all of the other things. And the web API, we can also scale separately if you deploy it separately as well, because if all of a sudden we get a lot of requests coming in, we don't want the indexing to suffer from the fact that requests are coming in to the web API. One thought on bindings. We did like working with those trigger bindings and those output bindings as well. But we also found that the more deeper you go into working with those custom bindings and writing those custom bindings, the more coupling you have to the framework that is Azure Functions Runtime. So if you ever think of moving this to Lambda or using an OpenFaaS or something else to run your functions, you probably want to do it slightly different and abstract away those bindings as well, because with those bindings, you're really locking yourself into the Azure Functions Runtime. On that note, I don't care, because the Azure Functions Runtime is really nice if you have those custom bindings, because your function can really do one thing, which is process whatever comes in and write it to wherever you want to write it to using such binding. So with that, thanks for being here, and I hope you enjoyed the rest of NDC. Thanks.